All right, here's a video for 8.3, practice A, and then I'll do a separate video for 8.4, practice A. So this is on geometric sequence and geometric series. So a geometric sequence is when you have a sequence of numbers separated by commas, where you have a common ratio, like where you multiply or divide. So like here, you're dividing to get to 32. Here you're dividing by 2 to get to 16. So you're dividing by 2 on all of them. That is definitely a geometric sequence. Number 2, you would be subtracting 22 on each one. That's definitely not a geometric sequence. It's an addition. That's actually an arithmetic sequence, if you remember from the last few sections. When you subtract the same number, it's arithmetic. We want it to be geometric. And number 3, you're again adding 0.9. So that's another arithmetic sequence, not geometric. Number 4, you're multiplying by 6. So yeah, every number gets multiplied by 6. That's geometric. So a geometric sequence is where all the numbers have a common ratio or a common multiplier or a common division. Like here, they're multiplying by 5. Or maybe you're going to be dividing or whatever. A geometric sum, where you have a geometric series and you want to get a term, you want to get a rule for it. So your formula is a to the n equals a to the 1, that means your first term, times the common ratio, whatever you're multiplying by or dividing by it to each number, and then your exponent is n minus 1, n being the same number as you had here. Those are both the same. We are going to be using this formula basically on every problem. So just look at that problem, know what it is. I write it down a few times. Okay, so we get to number 5. It says write a rule. Okay, so writing a rule means we need this formula that we just learned. Okay, so write the rule for a to the n. So a1 equals r to the n minus 1. So I'm going to take out the a1 and put in -5. First term, a1 means first term. And then I'm going to take out the r, 3 times greater, so r is 3, and put n minus 1, and that's done. That is 5a right there, this little answer. an equals -5 times 3 to the n minus 1 power. And that's just what we call a rule. That's just like a formula. You can now substitute any number you want in for n, and you can find that term in the sequence. If I wanted to find out what the fourth term was, I would put a 4 in for the n's, and I'd get the fourth term. Letter B, the first term is 54, and then the common ratio is 1/6. So it means it's actually dividing by 6 to get to the next number. So we would use 54 times 1/6 to the n minus 1 power. It's the same exact formula. A1 is your 54, R is 1/6, and then n minus 1 power. Okay, so that's how you use the formula. The A1 goes first, the R goes second, and then n minus 1 is the n is from what term you wanted. All right, now it says write a rule. They're going to just give you 4 geometric sequences, and they want you to write a rule for each one. So on each one, I need to know what A1 is and what R is. That's what I need on each one. So here's number 6. A1 is 3, and you're multiplying by 2, so your R is 2. So A1 would be 3 times 2 to the n minus 1 power. There's my rule. The rule is super easy. You just find out what the first term is, put that here. Find out what the common ratio is, put that here, and then put n minus 1. You're done. Boom. But they are asking us to find A7. So they want to say, okay, here's first 4 terms. What would the 7th term in this, if I kept multiplying by 2, what would the 7th term be? So you would put a 7 in for n. 7 minus 1 is 6. So you want to get 2 to the 6th power. 2 times 2 times 2 times 2 times 2 times 2. 6 times would be a 64. 3 times 64, 192 would be the 7th term in this sequence. So A7 would be 192. Number 7, let's see, your common ratio is you're multiplying by 3. So R is 3. Your first term is a 7. A1 is 7. So what we want to do then is plug that into our formula. So a to the n is going to be a1, 7 times the common ratio r to the n minus 1 power. So 7 times 3 to the n minus 1 power is your rule. Now again, we want a7, so we're going to plug in a 7 to n. So that's going to be 3 to the 6th power. 7 minus 1 is 6. 3 times 3 times 3 times 3 times 3 times 3. 6 times is going to be 729. 7 times 729, because we're bringing down the 7, you're going to get 5103 is going to be your 7th term. If you kept multiplying by 3, the 7th term would be 5103. That's 7. Number 8, you can see here that the common ratio is that you're dividing by 2. If you put 96 over 192, if you put the second number on top of the first number, you would see that it's exactly half, or dividing by 2. Okay, so that's going to be your common ratio then is 1/2. Put the second number on top of the first number and reduce, and you'll get the 1/2, especially if you're dividing. So dividing by 2, you're going to put the second number on top of the first number and reduce. You would reduce to 1/2. So a to the n would be the a1 number, which is 192 is my a1, and then 1/2 to the n minus 1 power. That's your rule. So if I wanted to know what would the 7th term be, I would put a 7 in here. 7 minus 1 is 6. 1/2 to the 6th power, 1/2 times 1/2 times 1/2 times 1/2. I made it a decimal, and it would be 0.0156. It would be like 1 over 64 as well. So you could have left it as a fraction. I just made it a decimal. When I multiplied, I get 3. So if you kept dividing by 2, if you kept cutting them in half, 24 cut in half would be 12, 12 cut in half would be 6, 6 cut in half would be 3, 3 would be your 7th term. Number 9's a little trickier simply because how did you get from 36 to 24? Well, like I said, you need to put the 24 on top of the 36. The second one goes on top of the first one, and then you can reduce that to find your r. Okay, so if I go ahead and put 24 over 36, okay, that's going to equal my r value right there, 2/3. So my first term is 36. My ratio is 2/3, n minus 1, that's my rule. And they want us to plug in a 7. So 7 minus 1 is 6. 2/3 to the 6th power. Again, I just left it as a decimal. Actually, I went to Desmos calculator, and I did parentheses, 2/3, end of parentheses. Oh, wait, no, hold on, not there. Outside of here, then end of parentheses. And then I shift 6 to get to the exponent, or you can put it up here too. And then I hit 6th power. That's how I got my decimal of 0.0878 when I rounded off, 0.0878, and then I multiplied that, you get 3.16. You could have left that as a fraction. It would just be a really big, messy fraction, but it would still work. You'd still reduce to 3.16 when you're done. So that was 6 through 9. Number 10, they want you to write a rule for n again. So we want to write an a to the n. That's our goal. But to do that, we need to know what a1 is. Because if you remember this formula, we need a1 the first term to do our rule. And in the problem, they gave us a3. They didn't give us a1. So a3 would be when we'd have a 3 minus 1 up here. So I'm going to plug in a3, which was 9. Put that in here, 9. a1 I don't know yet, but I got to find a1 for my rule. And then r is 3. Now 3 squared is 9. So I can just divide by 9 on both sides and get a1 by itself. Because when I divide by 9 on both sides, that means these guys cancel out right here. And you just have a1 equals 1. So now I can make my rule because I know a1 is 1. I know my ratio is 3. They gave me that. So 3 to the n minus 1. Just plug it into my formula and leave a to the n there. So that's your rule. So you just got to find a1. when you do number 11, they're giving you A2. So it's got to be 2 minus 1 up here because the 2 is here, so the 2 goes up here. And A2 is 12, so 12 equals A1 to the 4 to the first power. Now, I didn't put a 1 up there because you don't technically need a 1. But you can put a 1 there. 2 minus 1 is 1, but 4 to the first power is just 4. So if I divide by 4 on both sides, these will cancel. You'll get A1 equals 3. So that means that your formula, your little rule that we need, is a to the n, and the 3 is my A1, so that goes here. And then your r, and then n minus 1 for your rule. So 3 times r to the n minus 1 power. That's my formula. Because that's what we were talking about earlier. A to the n equals A1. In this case, it was 3 times the 4 ratio, n minus 1 power. So that was 11. Let's go to 12. Okay, 12 is on this side. Again, they're giving you A4. So that means it would be 4 minus 1 power, because n minus 1, you would plug in a 4 because the 4 is here. So 4 minus 1 is 3. A to the 4 is a 5. So we put a 5 in there for A to the 4. And we don't know A1, but we do know the ratio is a half. And I know that 1/2 times 1/2 is 1/4 times another 1/2 is 1/8. So I'm going to multiply both sides by 8 so that I can get rid of those 8s right there. That was not a good line. So I can get rid of these 8s. So they'll cancel out. And 8 times 5 on this side is 40. You got to multiply both sides by 8. So you get 40 for A1. So now I just go to my formula, AN. Now I know A1 is 40. I knew my R was a half. I already knew that. And then n minus 1 power. If this is an n, then that's got to be an n. So that would be number 12. And then 13 I did way down over here. Okay, so I rewrote kind of our formula. If this is a 5, then this is going to be a 5, which I plugged it in down here. But let me fix that here too so that it doesn't confuse you. Okay, so this would be a 5. Okay, so A5, you'd have a 5 minus 1. So plug in A5, and it does say that it does say that A5 is negative 208, and the ratio is 2. Okay, so negative 208 is A5. The ratio is 2. And we have 5 minus 1, which is going to be a 4. 2 to the 4th power. This is 2, this is 4, so 2 to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. So it would be 16, and the A1 would come down, and you would divide by 16. That would make those two 16s cancel out right here. And you just have A1, and when you divide those, actually you get negative 13. Negative 13. And then you would put your 2 back in and your n minus 1 back in. So that was 13. Your last one that you have to do here is 14, which we're just looking for the mistake. And so they switched the A1 and the R around. That was their mistake. It should be A1 first, then R to the n minus 1. So when you plug in your A3 right here, 147, it would be A1 to the 7 to the 3 minus 1 power, which is a 2. And 7 squared, 7 times 7 is 49. So if you subtracted 49 on both sides, A1 would be a 3. So instead of A1, which they had as a radical 21, that would not be right. They should have had, let me see if I put it in somewhere. Nope. They should have put A to the n equals 3. Let me write it in there for you. So A to the n equals 3, and then the common ratio was 7, and then n minus 1 power. That's what they should have gotten instead of what they got down here. That's not correct. So this is correct right here. All right, there is 8.3, practice A, geometric sequences and series. So you can see what a geometric sequence is here and what the formula is right here. All right, and we'll come back with 8.4 video next.